Good morning, Physics 20. I hope you guys are all doing well today. Welcome to lesson number 2. So, today we're going to be looking at uniform motion. So, this is the first topic of actual Physics 20. No more review. We're jumping into it. Now, some of these equations you will have seen before. That window above is really glary. Yeah, unfortunately, I need the plug-in for the computer, which is right there, and yeah, issues. So, you guys get glary screens. So, ladies and gentlemen, uniform motion. Let's look at this. Now, uniform motion is when an object is going to be moving the same. It's the amount of distance it's covering over the amount of time is the same. So its speed is going to be the same. Okay, we're not changing motion, we're not speeding up, we're not slowing down, we're staying the same motion. Now, when we let's look at the word uniform. Let's break that one down into its Latin roots, ladies and gentlemen. Latin, great language. So uni means one. Form is one form, or style. One style, one form. Uniform stays the same. All right. So these, ladies and gentlemen, very, very important terms here. You guys probably remember these from last year. So let's actually make a note here. For this one, constant speed / velocity. Okay? So, ladies and gentlemen, we got 2 vocabulary words you need to memorize, and it's vital. Vector and scalar. Now, ladies and gentlemen, I hope you guys definitely watched the original Despicable Me. It's an awesome movie. You guys remember the bad guy? Vector? My name is Vector! We commit crime with direction and magnitude! Exactly, it's a thing. So, vectors, ladies and gentlemen, are values that have both magnitude, so a size or a value, and a direction. And mathematically, we represent these by positives and negative values to indicate they're going in opposite directions or the same direction. So if we have 2 objects going one direction, we can make them both positive. But if we have directions going opposite to each other, one's positive and one is negative, and that changes your math. All right. Now, scalar values only have a magnitude. Okay, and they both have their uses, and it just depends on the scenario. And the direction is actually going to be very, very important when we're going to be dealing with opposing directions and angles and all that good stuff. Alrighty-o. So, ladies and gentlemen, displacement is a value that indicates the distance and direction away from a certain reference point of an object. So that's a value that you would have talked about last year. Okay, so it's essentially a change in position. So whether you're going to be moving 3 meters east from where you started. All right. And ladies and gentlemen, displacement is a vector quantity. Okay. So distance, this is scalar. Now, sadly, I can't get up and move around on a YouTube video lesson the same way I do in class. In class, I'd be running all over this classroom, and I'd be doing a bunch of silly things because it's what I do. But sadly, I can't do as many silly things on the videos because it's a pain in the butt to film. I'm using Screencastify, so I'm limited into how I can actually film stuff. So, but that's what I needed to do. So scalar values, it means that we don't take into account the direction. So if, I'm actually going to make myself a bit more space here. I'll rewrite this. There we go. There we are. So distance is a scalar value, so no direction. So if I am going to go 20 meters this way, and then I'm going to go 3 meters this way, and we're going to make this west and this east. Well, ladies and gentlemen, what will have happened if we go 20 meters this way and 3 meters this way? Guess what? What's the total distance? 23 meters. Okay. We don't care whether we're going east or west. Your feet plodded along the pavement for a total of 23 meters. However, Displacement, ladies and gentlemen, is a vector quantity. That means we care about the direction. All right, so in this case, we go west, east. Same idea. If we go 20 meters to the east, but then we turn around and go 3 meters that way, well, guess what, ladies and gentlemen? How far have you actually gone? 17 meters. Because we've gone backwards here, that means I need to make that 3 negative. So when I find my displacement, I've only gone a total of 17 meters. All right? Okay. And in what direction? If I started here and I went here, then turned around and came back here, I would have wound up there. East. Okay. So the distance covered was 23 meters. The displacement was 17 meters east. Okay, so there definitely is a difference, and you need to really watch that. And that's just one of the things you guys are going to have to memorize, unfortunately, about what is vector and what is scalar. So, and after time, we're going to be using this equation again and again and again and again, and you will eventually memorize just by simply using them which values are scalar and which are vector, and I'll always tell you in class which ones are which. All right, so ladies and gentlemen, velocity. This is another thing that you learned last year in Science 10. So velocity is the rate of change on an object's position. Now, what rate means is over time. So when we're looking at what is the rate in which you can eat a pizza, and you say, oh, I got great pizza consumption rate. Well, that means you can eat pizza very quickly. And you say, well, what's the rate in which you eat pizza? Well, I eat pizza pretty slowly because I'm a slow eater. So that means I would have a low rate of pizza consumption. I actually don't eat pizza very much because I guess my poor old guts issues. Yeah, Crohn's, thanks, I love pizza. I make pizza, though. Homemade pizza, so good. I should make pizza. I haven't made pizza in a while. But yeah, store-bought pizza, can't do that. Makes me sick. All right. So essentially, ladies and gentlemen, because velocity is the rate in which an object's position changes, that means velocity is a change in an object's position over time. All right. So your units are meters per second. It is vector. Big star. You must know that. So our velocity is displacement over time. Okay? Now, it's not just plain old displacement. It's delta D. What is delta, ladies and gentlemen? Delta means change in. All right? Now, on the data sheet that I gave you in September, now this one's crunched because I stuck my computer on top of it in the computer bag. And my computer, it's my husband's computer. For COVID, I had to appropriate my husband's Chromebook because it's got the fancy Chromebook and or the camera, touchscreen, microphone, you name it, all the bits. And so when I started making videos last minute for the shutdown back in March, like, I need to get a Chromebook. Go grab my husband's Chromebook, and he's just going to use his own computer much anymore, sadly. I've appropriated it. So you guys need to thank my husband for essentially giving up his computer. So you see this here on your data sheet. The data sheet will give you in September. Well, it's technically June right now, so we'll give you in September. When you're watching this, I will have given it to you. So it's like a space-time continuum thing. It's weird. I'm watching too much Star Trek lately. So you see this here? Okay. On your data sheet that you will have received by the time you're watching this video, that's where this is. But notice you have the delta D over your delta T, your change in time. Now, ladies and gentlemen, I need to then break this value up. Deltas can be broken apart. So for the velocity, delta always means 2 minus 1. Okay? So position 1 minus position 2 over your change in time. So time 2 minus time 1. We don't use this one very much. I just say, oh, this happened in 15 seconds, and that is your change in time. So T is your time interval. So we don't use that very much. But this one you'll probably be using. Okay, we use delta V more than we use delta D itself, but very important. Okay, delta means change. All right. So V is velocity in meters per second. D, displacement in meters. T is time in seconds. These little arrows over the top tell us it's a vector. Okay. Now, speed is similar to velocity, except speed is scalar. Okay. Now, the computer squashed all my formatting, which is annoying. So speed is V equals delta D over delta T, except D here, this is distance. Okay, so speed is equal to distance over time, your time interval. And whereas velocity is displacement over time. Okay, it's a big difference. I know it's a bit tricky because they sound the same, and your numbers are going to be different, and I will definitely be getting you to calculate speed and velocity off the same numbers. Lessons at hand. All right, so this is scalar. There is no direction. If I say scalar quantity, I don't want a direction with the answer. If I guess for a vector quantity, I want direction with the answer. Okie dokie? All right. All right, so another important thing that we're going to need to keep in mind, ladies and gentlemen, is we're going to need to look at our sign conventions. Now, the thing about sign conventions and all of vector quantities is that they are going to have positives and negatives. Now, this is standard. Okay, so all vectors are going to have a positive number if they have a positive direction. For the most part, east and north are commonly positive. Up is commonly positive. Now, once again, commonly. All right. There are going to be cases that we're going to be talking about later when we can use different signs for different directions, but we'll talk about that then. So this doesn't, I'm not going to say always. These are most often. So if you're ever in a pinch, make east positive, make north positive, make up positive. Okay, we're going to be using up and down, so up is also positive. Now, all vectors that have a negative value are going to have a negative direction or opposite to the positive directions. So if we're going this way, and then this guy's going this way, they're going opposite to each other, so one's got to be positive and one has to be negative. So south and west, we most of the time uses negative. Often, down can be negative, okay? So when you're given directions in a question, what's really important here, so when I say north, south, east, or west in a direction, in a question, convert that to positive and negatives before you do your calculations. And now that's the same with up and down. Because if we have one going west and one going east, they're opposites. And if you don't convert the signs to make it the appropriate directions, you're going to wind up with your question wrong. Okay, so this is super, super, super important. We're going to be doing this a lot. So keep that bit in mind. And I know you did a little bit of that last year in Science 10. Alrighty. So an object travels at a uniform velocity of 25 meters per second west. What is the displacement of the object after 10 minutes? All right, so let us do a calculation. So, example. Now, I'm also going to take this opportunity here to show you guys how I want you to show your work. Now, this may seem silly for a 3-letter equation that you've already mastered from last year, but when we get to projectile motion calculations, where you're going to have a full page of calculations, that's a different story, ladies and gentlemen. Okay, this is showing your work is ridiculously important, especially when it comes from marking. Help me, help you get the most grades possible. Put as much work as you can on the page and organize it neatly. Because if you make a little mistake, like you round your answer wrong, or you miss a number in your calculator and you get an answer that's wrong, and I can go back and I can see that you did everything perfectly on this big, beautiful written response question, take off half a point out of like 8. And yeah, there's definitely a question on your assignments. Not for this chapter, but the next one is like 8 points. And if you make a tiny little calculator error, 7.5 out of 8. Whereas if you don't show your work and I can't find it, you're going to lose a ton more points. So show your work very carefully, pay attention to it. And even if you do get a right answer and show no work, I still take off points. Okay, the process is more important than the final answer. Because once you learn the process, you can apply the process of rearranging equations and using the stuff to any scenario. All right, the process is more important than just the final answer. All right. Okay, so an object travels with a uniform velocity, so the velocity is not changing, of 25 meters per second west. Well, because west is negative, I'm going to make this guy my negative 25 meters per second. Okay, so just habits, good habits to get into. And then what is the displacement of the object after 10 minutes? Well, what is the displacement? Notice we've got the word displacement right after the word what. That means you've been asked to find delta D. So put a question mark there. After 10 minutes, we'll look at those units. Minutes, that's time. Notice how I listed everything out here. Once again, it may seem silly for a little 3-letter equation, but when we get to the big ones, this really helps. Because now I can see, well, I have a V, I am trying to find D, I have time. Then what you do is you go and pull out your data sheet, and you are then going to look at the equations that we've already used, and you can say, well, which of these equations has all 3 of those letters that I need? Oh, look, it is my V is equal to delta D over delta T. There we go. So, ladies and gentlemen, but we have a problem. What is my problem? Raise your hand. What's my problem? Time. Time is in the wrong units. We can't do time in units or in minutes. We have meters per second. This is minutes. You're going to get the answer wrong if you don't do this in matching units. So meters per second. All right. So my minutes, I got to convert this to seconds. There are 60 seconds in 1 minute. Okay. Minutes are on the bottom. Now, once again, I'm just assuming that you guys remember how to do unit analysis from the previous video or previous lesson if you were here for class. So what that means is that if you need help with that, just make sure you come see me. So the time is equal to 600 seconds, and you put that in your calculator. Well, the next step I need you to do is I need you to rearrange your equation. Okay, so I'm trying to find delta D, so I'm going to multiply both sides by delta T. I'm also expecting that you now are assuming that you guys are comfortable with rearranging equations now. If you're still having grief with this, come see me. Okay, so delta D is now equal to V times delta T. Well, I now have my displacement value isolated. So V, ladies and gentlemen, is the velocity, and at negative 25 meters per second. And then the time at 600 seconds. Now, I'm not going to deduct points if you don't put units in the middle. So you can show your work like that if you want, and that's okay. However, sometimes it is very, very handy to actually put in your units because you can actually do some mini unit analysis to see if did you actually get the right answer. Okay, so you're going to put that in your calculator, and you are going to get negative 15,000 in your calculator. Well, let's look at our units here. Meters divided by seconds times seconds. Seconds on the bottom, seconds on the top. The seconds cancel and we're left with meters. That's what we want. Well, I now need to put my answer with sig digs, units, and correct direction. I know that I want direction here because I said displacement. Displacement is a vector quantity. That means if you don't put that right of direction with your answer, I deduct points. I got a negative number. The fact I got a negative number, that means we're going west. Sig digs, 3 sig digs, 3 sig digs. So I want my answer to 3 sig digs. So 1.50, I have to put this in scientific notation because these are all significant, times 10 to the power of 1, 2, 3, 4 meters. And I got a negative number, so I drop that negative and I replace, and then I re-put that in west at the end. Okay. Now, I also do ask that you guys either underline or box your final answer. So then that way you guys can, or it's easy for me to see what you want me to mark. So if you box your answer, you are communicating to me that Mrs. Bray, this is the answer I want you to mark. Then that way I can mark that answer, so that way we're communicating clearly and I'm not deducting points for like a partial answer or something. So box your final answer or underline it or make it clear to me that that's what you want me to mark. Okay? Alrighty, ladies and gentlemen. So there's our example problem, and it is time for me to go eat some lunch. Mrs. Gorman is probably looking for me. Mrs. Gorman and I have lunch every day. She's awesome. So, ladies and gentlemen, I will be back to film the rest of this video after lunch. Food's important. Yes, no, I love food. Food's great. All right, see you after lunch. Now I can't stop this. Bye. Good afternoon. We're back. I have eaten lunch. We're good to go. So, ladies and gentlemen, the next thing we're going to be looking at is a very important concept called average speed or average velocity. Now, that is going to be your key word, ladies and gentlemen, that word average. So if I say calculate velocity, I want velocity. And if I say average speed or average velocity, you're going to be using a bit of a different approach to that equation. So, ladies and gentlemen, when you see average speed, we'll look at average velocity first. Okay, so if I say average velocity, what I would be looking for would be your displacement total divided by time total. So the total displacement divided by total time. Okay, and now for average speed is going to be distance average divided by total. There we go. That's better. Distance total divided by time total. Okay, so watch out for that. This is distance, and this is displacement. Okay, so remember from earlier in the video what the difference between these two guys is. It is really important that you remember that difference. Okay, all right. So ladies and gentlemen, big star. That is not what I'm looking for. There you go. Big star. Keep that stuff in mind. Don't forget that, because you are definitely going to be seeing questions that are going to be involving total distance and total time. Okay? Okay. So we're going to look at a few examples here, ladies and gentlemen. So this question here, we've got a runner goes for a run and ends up going 572 meters north, 2 meters south over an interval of 3.75 seconds. All right, calculate average speed and average velocity. Okay, so ladies and gentlemen, average speed. Well, let's see what we've been given here. We have been now speed. Remember, ladies and gentlemen, speed is scalar. Because speed is scalar, do we worry about direction? No direction in scalar. So, well, we've gone a distance one of 5.72 meters. We went north, but this is speed, so we don't care about direction. And then distance two, we went 2 meters with a time interval of 3.75 seconds. So that's our total time. Well, for our average speed, we are going to have a total distance divided by total time. Okay. And then we are going to then take our distance total. It's 5.72 plus 2 meters. Okay. We're looking for the total distance that was covered divided by your 3.75 meters. Now, when you put this into your calculator, you need to be careful, because remember what I mentioned earlier in a previous video, that anything that is on the top is considered to be in brackets. So 5.72 plus 2 divided by 3.75. So what that means is you are going to have 7.72. That's messy. Okay, so 7.72 meters. Okay, that's an S, divided by your 3.75 seconds. Okay, so you don't have to write this step down if you don't want to. You can just solve it from there in your calculator, but this is what I need to see calculator-wise. Okay, this needs to be done first, and then you do the dividing. So your average speed, ladies and gentlemen, is with your correct units in sig digs, is going to be 2.06 meters per second. Now, because this is scalar, I do not need to see direction. Okay? Okay. So we're now going to look at part B, which is going to involve your displacement. Okay, I'm going to switch colors and I'll do part B in blue. Okay? So for B, well, now we're looking at displacement. We are no longer looking at distance. Now, what's the difference between distance and displacement? Direction. Displacement is vector. Distance is scalar. So, well, this one, we went 5.72 meters north. That's positive. Displacement 2. Well, we went south. Minus 2 meters. That's the difference. Time is still going to be the same. Okay? So when we come over here for part B, for our calculations, we are going to be looking at average velocity is going to be displacement total divided by your time total. Okay? So we've got 5.72 meters plus negative 2 meters. All right? You got to remember that negative. That's going to become important as soon as we get into displacement and velocity. Then the time is going to be the same. Time is never negative. Time is scalar. So remember, you have to do the top first. Okay? When you put this value into your calculator, you're going to wind up with a positive number, so 0.992 meters per second. Okay, well, we need to rewrite this with our appropriate direction. So our average velocity, sig digs, okay, 3 sig digs, units, direction. Okay, I want to see that direction written afterwards. Okay, you need to know, you got to do that. That's important. It may not seem like a huge thing now, but when we get later on, when we start having directions as angles, trust me, it's important. All right. All right. So, ladies and gentlemen, on to our next question. Now, this one is tough. This one is a tough one. So, ladies and gentlemen, I want you guys to put a star beside this guy. And I want you to write on test. In written response on your first quiz, you've got a question like this one. Less than subtle hint. So, here we go, ladies and gentlemen. In a high-speed car chase, the felon is driving 12 meters a second east for 7 minutes. He pulls on the emergency brake and does a complete 180-degree turn. He then proceeds to travel 18 meters per second west for 15 minutes before arriving at his destination. Calculate average speed, calculate average velocity. Okay. Well, we have a bit of an issue here, ladies and gentlemen. I've given you speed and I've given you time for 2 different stretches of motion. And if I want average speed, I want total distance over total time. So what do we got to do? How are we going to approach this? If you said calculate distance first, you are correct. So we're going to start with A. Now we can use some of our calculations for A and B. So we're going to do that. So I'm going to call each of these 2 different types of motion. So we'll call this first one motion 1. All right, so we're going at 12 meters per second east for a time of 7 minutes. And for motion 2, he's going at 18 meters per second. Now we did 180-degree turns. So that means we're going, and it even says there, we're going west. And we are driving at a time 50 minutes. Okay, so let's do some unit conversions here, because what issues are we going to have with these times? They need to be in seconds. Good. So we're going to convert this, so 60 seconds per minute is going to give us a time of 420 seconds. We multiply this by 60 seconds per minute. Seconds are going to, minutes cancel, and we wind up with 900 seconds. Okay. Well, we need to find the distance or displacement here. Let's find distance, and then we can add directions on it to make a displacement as we need to. So we have speed, we got time. What equation do we use? Good. V equals d over t. This is uniform motion. We can use this equation. So I'm trying to find d. I multiply both sides by t. So when I multiply by t over here, that cancels. Multiply by t over there. Okay? So then I'm going to get the speed of 12 meters per second, and I multiply that by, or the distance, 420 seconds. And we're going to get the displacement here, which is going to be 540 meters. I'm going to repeat the process. I'm going to just rewrite out the equation I already rearranged. It's the same thing, so I don't need to show my work again because I've already shown it. You don't need to be redundant in that case. So the speed here is 18 meters per second for 900 seconds. Okay, so we multiply those two numbers together, and we are going to get 16,200 meters. All right, so we have our scalar values here. We have average speed of the vehicle. Okay, so I am going to write up my equation. So V average is equal to distance total over time total. Okay, so for that, ladies and gentlemen, my total distance, well, I need to take these two numbers here. Okay, so 5040 plus 16200, okay, total distance, we got to add those together, divided by the total time. All right, so we have our total time of 420 seconds plus 900 seconds. All right, okay. So for your average speed, once you put that into your calculators, you wind up with 16.09 repeating. Now we need sig digs in units. Well, 2 sig digs, 2 sig digs, 2 sig digs, 2 sig digs. So I would need 2 sig digs. And that 9, okay, 0.99. Okay, well that would round that up to a 1, so we don't need that. I would round down, so 16 meters per second. Box your final answer. All right. Okay. That's your average speed. Now we're going to need to calculate the average velocity. Now remind me again, what is the difference between speed and velocity? Vector. Velocity is a vector, so we need to focus on that direction. Okay. I'm going to do B in blue, okay, to make it easier to see. I'll draw a line here. There we go. Starting to run out of some space. There. Okay, so we have our average velocity is going to equal our total displacement over our total time. All right. Well, let's look at what our displacement is. Now, this guy is traveling east. So that means he needs to be positive. So that means this would be positive. So this would be positive. So positive 5040 meters. Now we're going to come over here. We're going west. Remember that west is negative. So that means it's going to be negative 18, which is going to give us this number to be negative. So plus your negative 16200. Okay? So that is going to be very different now. All right? So you're going to have to add those two values together, keeping that one negative. However, time is going to be the same. We are not time travelers here. Okay? So when you put this into your calculator, it'll be this plus that negative number, and we're going to wind up with negative 8.45 repeating. All right? Okay. So we are now going to put our final answer together. And this, ladies and gentlemen, we have, because it's negative, it's going to be west. We want 2 sig digs. That 5 is going to round that guy up to a 5. So we're going to have 8.5 meters per second west. Okay. So please don't just leave the negative. I want you to take out that negative and use that negative to indicate direction. Alrighty-o? Okay. So, ladies and gentlemen, I've got some practice problems here for you guys in your workbook. Give those a shot. See how you do. Check your answers in there. The answers are all in that workbook for good practice. And we will see you guys next video. No fires, injuries, or explosions. We will talk to you guys later. Now I can't stop the video. There we go. See you guys.